we're off. We're going to talk about three things today, okay? We're going to talk about energy, and we're going to talk about momentum, and we're going to talk about two types of energy. So you remember from junior cert this idea that energy is the ability to do work. Very strange kind of idea. But we're going to look at two things first of all, okay? And I want you to take this down now in a copybook as you go, okay? So you have kinetic energy, okay, which is energy due to position, energy due to movement, kinetic movement, okay? And if you think about it, if something has energy, if it's moving, the bigger it is, the more energy it'll have. And that's its mass, and the faster it's going. And remember, the faster it's going, we talk about velocity, okay? So velocity or speed, we're going to use the word velocity, we'll come back to the difference later. Okay, the velocity is also important. And we have a formula that we're going to practice today, okay, which just says that the kinetic energy, so E for energy, and you put a little k in here, is a half mv squared. Okay, looks a bit dodgy, but we'll see how straightforward it is now in a minute, okay? Second type of energy is potential energy. And you wouldn't have come across these formula before, okay, but the potential energy is its energy due to its position, to where it is. Okay, so if you have a book on top of on a top shelf, it has potential energy, because if it falls, it's going to turn into kinetic energy. If it hits you in the head, you'll feel the energy, right? So we have a formula for that as well. Okay, and the formula is E again and P M G H. Okay, so M again is mass, H is the height, and G is, well, if you drop something, let's think about it. If I drop something, right, what happens to it? It changes velocity. We're going to look at this in Wednesday's class, okay? It accelerates, it gets faster, okay? And it accelerates due to gravity. And we've a thing called G, which is the acceleration due to gravity. And we're going to look at this in detail later, not today, okay? But G is always 9.8 meters per second, and you'll always be given that, okay? You'll always be given that, so there's no worry about that, okay? So that's that. I was going to do momentum today, but I'm not now, okay? We're just going to do the two of these, okay? So, questions, okay? And all the questions are going to be exactly the same idea, the same method is used, okay? And this is where it's important you get the idea of this and you have to work with this, because this applies in maths as well, okay? You'll be doing things like this. Okay, so I'm going to do two questions, okay? And what you're going to do then is I'm going to give you an assignment with just examples of those questions to do, and also a few little clips, other clips to watch from YouTube, okay? And then you're done for the day. So let's take the first question, okay? A body of mass 10 kilograms has a velocity of 4 meters per second. What is its kinetic energy? Okay, there you go, right? So what we always do, and you're going to practice this today now. On the left, you write down, you make a list, okay? You check it twice, right? A body of mass 10 kilograms, what letter do we use for mass? M, 10. Has a velocity of 4, that's the speed, and it's V. And we're asked for the energy, okay? It's a kinetic energy question, so you use the kinetic energy formula. You'll be given the formula always, okay? So E is a half mv squared. You write that down. And you fill it in. You don't know what E is, but you know what a half. You know the mass is 10, and you know the velocity is 4 squared. You put out the calculator. 4 squared 16, 1060 by half is 80. And you have to say what it's measured in. What's energy measured in? You all remember? Indeed, I hear you all shouting it out to me. It's the joule. Okay, so 80 joules. That's it. That's what I want you to be able to do. Okay, we're going to do now the potential energy one. Okay. Okay, and by the magic of technology, we have the question here. So a body of mass 40 kilograms sits on a shelf 60 meters above the ground. What is its potential energy? And you'd have to be given G is 9.8 meters per second. Okay, so you make your list. Mass is 40, M is 40. Height is 60, and G is 9.8. Okay, G is 9.8. You're asked for the potential energy. Okay, so EP. So you look for which formula, which of the two formula. It's going to be the lower one. EP is equal to mgh, and you fill it in. So m is 40, G is 9.8, and H is 60. Okay, your business. Multiply it out. Second, calculator. So we 40 by 9.8 by 60. So 40 multiplied by 9.8 multiplied by 60, and you're getting 25,350, and again it's energy, so it's joules, right? There are two calculations I want you to be able to do, okay, to start with. Okay, how to get potential energy, how to get kinetic energy. I'm going to give you a couple to do as an assignment, which will take you 3 or 4 minutes. I want to see it done like that, and I want it sent to me today, okay, at some stage, preferably before 20 past 10. You might as well do it now. Okay, there's also a clip or two to watch, okay, as well as this clip. So watch those first, then do the assignment, and then you're done. And we will talk tomorrow. We'll have a live class to begin with tomorrow, remember, starting at 5 to 2 tomorrow. Okay, very good. Talk to you then.